After Ørsted discovered the magnetic effect of current, many scientists were thinking about, since current can produce magnetism, could magnetism produce electricity? Since current has a magnetic effect, could magnetism also have the effect of current? According to the principle of physical interaction, this result should be obvious. So many people did many experiments, tried to discover the current effect of magnetism. However, this phenomenon was not discovered by British physicist Faraday and physicist Henry until more than a decade after Ørsted discovered the magnetic effect of current, and American physicist Henry discovered it. In 1820, the famous Danish physicist Ørsted discovered the magnetic effect of electric current. People were convinced that current could produce a magnetic field, but the reverse. Could magnet produce electricity? Many physicists conducted painstaking explorations for this question. Among them, the most productive was the British physicist Faraday, from 1821 to 1831. Faraday spent 10 years from conception to experiment, through long years and the pain of failure. Faraday experienced all kinds of bitterness. After countless repeated research and experiments, he finally discovered the phenomenon of electromagnetic induction. He proved by experiment that electricity can not only be converted into magnetism, but also electricity can be transformed into magnetism. Electricity in motion can induce magnetism, and magnetic fields can also induce electricity. Faraday's discovery provided the basis for large-scale use of electricity. Later, people used Faraday's law of electromagnetic induction to make induction generators. From then on, the steam engine era entered the electrical era. How to obtain current from a magnetic field? By electromagnetic induction. The experimental device in Figure 3 consists of a horseshoe magnet, a conductor, an emitter, and a wire. The operation method is part of the closed circuit. Conductor is placed in the magnetic field, and the conductor is stationary. Finally, the pointer doesn't deflect, indicating that there is no current. When the conductor is parallel to the magnetic field movement, the pointer does not deflect. There is no current. When the conductor is perpendicular to the magnetic field movement, the pointer deflects. There is current. The conductor moves diagonally in the magnetic field movement, the pointer deflects, and there is current. Electromagnetic induction is part of a closed circuit. When a conductor cuts, when the conductor moves, an electric current will be generated in the conductor. This phenomenon is called electromagnetic induction. Induced current. If a conductor or coil is connected to a closed loop, there will be current in the circuit. The essence of electromagnetic induction is to generate a power source. The electric motive force of this power source is called induced electric motive force. Second, the induced electric motive force of a straight conductor. When the direction of the magnetic field and the direction are perpendicular to each other, the induced electromotive force in the conductor is E is proportional to the conductor's movement speed V. The effective length of the conductor in the magnetic field L, and the magnetic induction intensity B, that is E equals B times L times V. Third, the induced electromotive force of the coil. Let the number of turns of the coil be N, which is the number of direct changes per unit time, divided by dt. Then the induced electromotive force is equal to times the direct change rate. The magnitude of the induced electromotive force is proportional to the direct change rate and the number of turns of the coil. Please guess. What do you think the direction of the induced current may be related to? Which factors? The direction of the induced current in the current, the direction of conductor cutting magnetic lines, and the direction of the magnetic field. The method of judging the direction of induced current can be judged by the right-hand rule. The right hand rule is to stretch out your right hand with the thumbs and index fingers perpendicular to each other. Let the magnetic field lines pass through the palm. The thumb indicates the direction of conductor movement, and the index finger indicates the direction of induced EM. Various generators are based on electromagnetic induction. The earliest application of electromagnetic induction from the Sensio hydropower stations 71 kilowatt generator set to small generators for automobiles are the earliest, most typical, and the most basic application. Various transformers also use the principle of electromagnetic induction to achieve voltage changes from high to low or low to high, and will achieve the isolation of high and low voltages. In this class, we learned about magnetism generating electricity, which is the electromagnetic induction principle. After class, please think about in our daily life, besides generators and transformers, what other devices also work based on the electromagnetic induction principle. Problem E. Please think about what are the conditions for electromagnetic induction. Second, please consult relevant materials and briefly explain the working principle of the car AC generator.